Hello, guys. This is David, aka Booleaninator, and I'm getting back to what started me on YouTube, which was educational. I started a series called Bring in the Logic Probe, which is a reference to Tron. And Tron, of course, is about what's going on inside a computer, because that's what I do for a living. And I was talking to somebody over in Soundly's 24/7 live chat who pointed me to a fellow out there on YouTube who is a little confused onto how binary works. So it kind of reminded me that, yeah, I was doing this series at one point. And I never got around to actually completing it. So the first two episodes covered the logical premises. Hello, Spooky. And the logical premises included law of identity, law of non-contradiction, and a law of excluded middle. Then we got into gates, which was not and, or, XOR, which are also known as product, kind of a adder, and then a half adder, or product and sum. And now we are going to actually get into some binary. So this binary stuff, which is what kind of got me to go back to this, because this other guy was talking about binary being the language of the universe, and everybody thinks in binary, which is patently false, because I don't know anybody who can remember phone numbers in binary. That's just bullshit. So we're going to drop that little bomb right now. Nobody thinks in binary. We like words. We as people like words. So inside the computer, we represent the numbers that the computer thinks is. We have these abstractions. We have character sets and so on and so forth. Hello, Christopher. And these character sets, of course, allow us to translate those into numbers and so forth. So what we're going to do is we're going to actually talk about how computers think. So everybody knows that a binary digit is called a bit, and 8 bits is a byte, and so on and so forth. But what you don't know is, a lot of people don't know anyway, is that 4 bits is called a nibble. And there's a reason we care about 4 bits, because we also know that hexadecimal is in use in computers a lot too. So we'll get to that in a minute. So your basic binary is ones and zeros. And the reason that's important is you have ones and zeros in the truth table for your gates. So a bit can either be 1 or 0. So it makes sense that we have to have a number system. And binary is the logical choice, because you could still represent any number you want. And those can carry over. So if you've got a number, let's say the number 3, which is 1, 1. And let's change the font in this, which I'm not really sure how to do. Let's make this a little bit bigger. There we go. And let's add 1, 0 to it, which is the number 2. Let's make this box a little bit bigger. Nope. Damn it. Okay. All right. Paint is probably the wrong program to use for this, but we'll go ahead and use this. So we'll just do File, New, don't save, and we'll just do a massive text box. So we'll do 1, 1, 1, 0. What does that give us? Technically, it gives us 5. So how do we get to 5 with this? Just like you would in decimal. But remember, you only get 2 symbols. It's binary. In decimal, we get 10 symbols, 0 through 9. Because 0 counts. So we start with the 1 and the 0, and we get 1. And then we start with the 1 and the 1, which is 2. But we don't represent 2 because we don't have a symbol for 2. 2 is 1, 0. So that's our answer. Which, if you add that up, that's the 4's place. And that's the 1's place. 4 and 1 is 5. So that is the number 5 in binary. So that actually works. The only thing that's confusing about this mess is that it doesn't line up correctly. So the next time we write these numbers, it probably would make more sense to line it up like that, so it looks like where these things line up. So that's what happens with 3 digits. Now, ironically, 3 digits can be translated to octal, and you'll see octal in some places in computers, but not very often. You used to see it a lot more in the old days, particularly in Unix with permissions. File permissions are done in octal in Unix. Paint is probably the wrong program. Thank you, TomTom34B. I know, but Paint is the easiest to share, and it's on every computer, so I figured I'd use it. I don't really have anything else to use to do this, so let's face it, it's there. So what's a nibble? So nibble's a 4-bit number. Why is that important? Because people tend to like larger representations. They're more succinct. It's more easy. It's easier. It's easier to deal with hexadecimal, which is key when you're programming in machine code, than it is to see things in binary. So let's take some hexadecimal nibbles, or let's take some nibbles binary and translate them into hexadecimal. Let's take 1101 and translate that into a hexadecimal digit. So what is that number? Well, that number is 5 plus the 8, so that's 13. Well, we can't just say 13 because that's a decimal number. So we use A, which is 10, B, which is 12, or 11, excuse me, C, which is 12, and D, which is 13. So we use D. That's actually D. Well, that's well and good, but what happens if we get a larger number? What happens if we get an 8-bit number, which is a byte? Well, it's very easy. So if we got 0101 and 1101, which, if you look at it, is actually quite a bit bigger, it's still 5D in hexadecimal because you just split it on the nibble. That's why nibbles are important, because you don't need to worry about, it's so much easier to turn into a hexadecimal number than it is a decimal number, because you don't have to worry. You just split it right there. And this becomes 5, and that becomes D, and there's your hexadecimal number. Yep, that's why hexadecimal is so much easier than decimal when you're dealing with machine code. So, and that right there is a byte, and bytes are what we use for the character set for the most part in the computer. It's very succinct. It gives you 256 possible combinations, 0 through 255. So that's plenty to represent 26 ABC A through Z and 26 lowercase a through Z, the space bar, pretty much everything on your keyboard, and a bunch of control characters and things like that. Plus, if you look at the high digits, which is what you get if you turn the top one on, like if you anything that starts with a 1, so starting with that start special characters in IBM land. And so that is actually 127. Or 128, rather. Sorry. My fault. 127 would be everything before that with all ones. So 128 starts the special characters. You could draw all kinds of fancy pictures with those. There's lines. There's all kinds of cool stuff in there. They're called the high ASCII numbers in IBM land. And then you have UTF-8, which is a whole different ballgame. You might see UTF-8 around a lot on the internet. So that's kind of what we get when we deal with binary. So when you add binary, it's quite easy. It's just like adding in decimal. What about subtraction? Well, you could subtract the old-fashioned way, but there's a much easier way. Let's say we got two numbers. Let's do the first one. Let's say we want to subtract 2 from 3. Well, that would be 1, right? There's a much easier way to do that. So we've got 2, or we got 3. We can actually invert the 2 and add 1. So we can do 1, 0, 1 and add 1 to it. So that would be 1, 0, and then we can add it and throw away the carry. And we'll get the same answer. We'll get the actual correct answer. So we'll get 0, 0, 1, because 1 plus 0 is 1. 1 and 1 is 2. We carry the 1 out. 1 and 1 is 2. We carry the 1 out, but we throw that carry out. So we get 0, 0, 1. And that's how computers actually do subtraction. It's called 2's complement. That's why computers are so fast at addition and subtraction. How does binary handle negative numbers? That's a very good question, Chris. They actually handle them in 2's complement. So let's say we have a byte, right? Let's go back to the byte again. So this is a 2's complement number because the first digit is a 1. So to take a 2's complement number, which is a negative number, and turn it back to find out what its actual value is from the positive, the actual integer value that is negative, you do the same thing. You invert it. So we would invert it. You do 0, 1, 1, 1, 1, 1, 1, 1. And then we add 1 to that. So we get actually get, 1, 0, 0, 0, which kind of is an ironic case because you technically throw away that carry, so you actually get 127. It's negative 127. It's actually a special case. Let's take a different negative number. Let's take this negative number because the first digit indicates it's a negative number. So let's invert that. And add 1 to it. So that's actually negative 1. Even though if it was an unsigned number, it would be 255. So that's how we handle negative numbers in a computer. And that applies to any length of number, all the way up to the 64 bits we deal with in our today's computers. So point blank, that's subtraction. So what about multiplication and division? what do we do with that? Well, multiplication division is a little bit trickier. Although not so much, because multiplication is easy, actually. If you shift the bits to the left, that's equivalent to multiplying by 2. But you can't throw the carrier out. You can't throw the carry out. You have to keep it. If you have a carry out, that's an overflow. That means you've lost information. So let's say we have the number is 2. We shift it to the left. Now we have that is 4. That's a multiply by 2. If you want to multiply that by 3, that's a different ball game, because now you have to multiply by 2 and then add it back in. So you just add it again, and then you have to have math functions. So then you get 6, which is what that is. Multiplying by 2, division works the other way. And you can put a binary point in there if you need to. Obviously, that binary into decimal point, you've got the halves place, the quarters place, the eighths place, the 16th place, the 32nd place, the 64th place, the 128th place, the 256th place, the 512th place, the 1024th place, and so on and so forth. So it doesn't translate exactly into decimal. And floating point is not represented that way in a computer. Floating point is represented as a number between 0 and 10, and then it has an exponent portion. So it's 10 to the exponent, which is also stored as an integer. So that's what we do, but we're not going to get into floating point. This is just basic integer addition, subtraction, multiplication, division. And this is so I have something to show that guy. I can reference a video and to kind of expound upon this. Because at some point, we are going to use a clock to increment a counter, which is going to use binary numbers to count the states for our stoplight. We need to figure out how many states there are for a stoplight. And we're going to count those states, and then we're going to reset our counter. And our counter is going to be a chunk of memory that holds a binary number. We're going to use that state so we can figure out which lights to turn on and which lights to have off. That's basically how a stoplight works. Simple, right? And with that, I am done. Yes, Christopher, that is correct. 1024 bytes is actually a kilobyte, though. Forgot the kilo. Everybody forgets the kilo because nobody uses them anymore. But yeah, 1024 bytes is a kilobyte. 1024 kilobytes is a megabyte. 1024 megabytes is a gigabyte. Yep, everybody forgets the kilo because the last time anybody used kilobytes was probably 30 years ago. So anybody have any questions from the chat? If not, this is going to be short and sweet and to the point. Unlike my other Bring in the Logic Probe series, which went on for 40 minutes when I was a little unsure myself. how does hex code is more for the human benefit than the machine benefit, Christopher. It's so that we can translate it easily in our, to look at something easier. Mostly for like if we're gone opcodes. Hex. Oh, you want me to go over hex? I could do hex. I'm not going to go how to add it other than addition. Well, the games themselves are not in hex. They're just represented that way in the editors, but hexadecimal code is we use decimal as human beings. Code 0 through 9, 10 digits. So after 9 comes 10, which is 8. So we've got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, and F. And that represents literally 10, 11, 12, 13, 14, and 15. So in every base, it's that base to the place power. So in 16th, in base 16th, it's 16 to the 0 power. After that, you got 16 to the 1 power. That's the second place. You got 16 to the 2 power. As far as places go, if you were in base 10, 10 to the 0 power is 1. 10 to the first power is 10, but in this case we're in base 16. And 16 to the second power is what? Quick, come on. 16 times 2, 16 times 16, rather, is what? No one? No one? Think? Am I right? No. I think it's 128. And if I could type. That can't be right either. Something's off with that. 256. That's what it is. Or should I just pull out the calculator and be sure? Because I don't want to actually be wrong with this. See, I don't think in hex like this. This is why we don't do math in hex. Nobody does. It is 256. So we got the 256 place, the 16 place, and the ones place. Those are the first 3 places. So, and you could use symbols 0 through F. So in the ones place, you can literally represent numbers through 15. And then you have to carry out into the 16th place. And then you can go up to 15 again. So 16 plus 15 up to 31, all the way up. And then 32 is 2 16s, and so on and so forth. And it works just like decimal after that. You can borrow just like decimal. You can add just like decimal. You multiply just like decimal. You line it up just like decimal. You can divide just like decimal. It literally works the same way. You could do that with binary too, but it's kind of pointless because binary's only got the 2 symbols. So there's a lot of shortcuts with binary, like shift left and shift right, to do multiply and divide by 2. So typically hexadecimal is used for shortcuts for people so that we can see these nibbles and it takes up less space on the screen and it's easier to remember. Like there's in the Commodore 64, there's opcodes for machine language instructions. It's much easier to memorize the opcodes in hex than it is to remember 8-bit codes in binary. So when you're programming games in machine language, but then most people don't program in machine language. They program in assembly, which is even better because you have mnemonics, which are things like LDA for load the accumulator. But we won't get into machine language because we're not talking about microprocessors as yet. So anyway, any other questions? How much interaction do I have to machine language? I invent the stuff. I'm a microprocessor engineer. So when I actually create a new microprocessor, I'm the guy who figures out what the opcodes will be for that microprocessor, what registers exist on that microprocessor, and by extension, what modes will exist for each opcode and what opcodes are available and what the microcode will look like on that microprocessor and how prefetch works and pre-execution works. So you don't end up with stupid shit like what Intel did 20 years ago with that huge vulnerability. So yeah, that's kind of what I do for a living. So this stuff is old hat. This is a 400 level class for me, basically, that I'm giving you guys. What's my favorite OS? Ooh, loaded question, Don. Loaded question. It depends on the task. I'm kind of into virtual machines. Let's put it that way. Like on my home computer, I run Zen, and Zen passes the video card onto Windows by default. So I can, do streaming and stuff like this. But, it's got a Linux DOM 0, so it's always running Linux in the background, and I can pull up that, I can SSH into that basically from the Windows machine. And it's literally running on the same machine on 2 processors, and the other I'm trying to think. It's been a long day. The other 14 threads on my Ryzen 7 are actually dedicated to Windows. Linux is something I prefer for my day-to-day tasks. But Windows is really one of the best ones for streaming because do I have dual CPUs? No, I have a Ryzen 7. So it's got 8 cores with hyper-threading, so it's 16 cores. Apparent. No, midichlorians. No, don't talk about those. We don't talk about the first 3 Star Wars movies, just like we don't talk about the odd number Star Treks. So yeah, anyway. It's cool to have at least, 7 people watching because my first stream I had like 2, 3. Although no one's asked to join yet. No one's actually even come in to the hangout. But anyway, it'd be nice if someone did. Star Trek 3? You liked that? They beat up. Was it the Klingon comedians? Dan Larroquette and what's his name? Christopher Lloyd. Yeah, both of them are played Klingons, which is funny as hell because those are such serious characters, and you get 2 comedians to play them. 5 was ridiculous, though. I hated that one. I hated 5. And one could have been an episode if they had cut all the bullshit out of it. So anyway, I'm definitely gonna stop all that. I don't need to look at that anymore. Yeah, everybody liked the return of Spock because Spock can't die. There's obviously an issue between Paramount and Leonard Nimoy at that point in time because Leonard Nimoy basically said, "You better let me direct a couple of these things, otherwise I'm not coming back." You can come in, Christopher. I'll send you the Hangout link. Discord. Oh, the topic is done. I honestly, I just wanted to get that in there because I haven't done one of these in a long time. I've been kind of focused on Flat Earth and G-Man, and it's just I'm tired of their crap, to be honest with you. I really don't want anything to do with them on a personal note. It's just such crap. They're not really worth my time. It's just not. So let me get the Hangout link for Christmas. And it's in Discord. Yes, long time, months, Spooky. And months in internet time is very long. And I think my confidence has gone up a lot. I've done enough Hangouts, hosted enough debates on the Great Debate Community, and opened enough Discords and Hangouts on my own to basically say, hey, fuck it, let's open one of these. Where's my actual Hangout? Show and broadcast. Hey, Chris. Can you talk? Are you talking? Am I just not hearing you? It's possible I'm just not hearing you. Hold on.
There we go.
There we go.
Hold on, I came in.
So how are you doing, bud?
Stomach problems, but it's just an upset stomach. I'll get over it. I didn't feel like I was going to stream today, and I was like, I just don't feel like
it. Well, you know, it's amazing the kind of stuff you run into when people they misinterpret things. It's this guy was saying that binary is the most efficient storage we know, and I'm like,
No.
for computers, it's pretty efficient, but it's not the most efficient storage we know.
Not really.
Not really, and we don't think in binary as people.
Yeah, it's hard to think in binary because it's a complex language that's.
It's not even a language. It's just a numbering system.
I think of it more of a language because it's something that computers use to speak to each other. So technically, it is a language now because they actually speak using binary.
Yeah, but we have to have a layer of abstraction on it. Like we have TCP/IP on there, we have Ethernet on there, and if we don't have those layers of abstraction, we can't just send ones and zeros and expect the other end.
Yeah, but when we
really interpret that as anything other than changes in voltage.
But when we type, say, the letter A, it goes into the computers as a series of ones and zeros.
Yes.
And then it comes back to our computer as the letter A.
Right.
So every time we type basically in a language that the computer understands. And then we send that to another computer where it's translated from the zeros and ones back to our language.
Yeah, I mean, but we come up with that representation, like the code ASCII is something that a person came up with. It's an abstraction a human came up with.
But then there's Google Translate, which has gone a step farther and developed its own specific language to act as a go-between between other languages.
And it sucks.
Yeah, it sucks, but it's
better than nothing.
It's better than nothing. You can get the general gist of what the people are saying. And again, that's translated through binary again. But no, actually, no, it's not. No, it's not even translated through binary in Google Translates. It's, like I said, it's so developed that it's got its own internal language.
It's a database, yeah.
Yeah, and it was confusing at first to the actual programmers because they were not expecting it to evolve that quickly, that's exactly what it did. It evolved. It's a language that evolved on its own.
Yeah, my ex might say I am a 0, but she knows I'm a 1 because I'm a cash cow.
Catch me outside. How about that?
She's a gold digger. That's for damn sure. I had a case of the X earlier today, but we won't get into it.
Right.
She asked me why I resent, giving her alimony. I'm like, do you seriously have to ask me that question? Yes, I agreed to do it. Probably, because I didn't have the money to go back to court and fight it and pay my lawyer at the time. So I just agreed to pay her on a monthly basis. Do I resent it? Of course I resent it, because if I didn't have to pay it, that's $1,600 more a month. I'd have it in my pocket.
That's why I avoid human contact as much as possible.
Well, I'm just avoid putting the state in my business at this point in time. That's never fucking happening again. Marriage, you can keep that stuff. If the gay people want to get married, if gay people want to get married, straight people want to get married, hey, let them.
I just can't wait until they make a gay divorce court.
I want to see my first gay divorce. That's going to be fun.
That's going to be.
They should put that on national fucking television. That's going to be hilarious.
Yeah.
Especially two drama queens.
Whether it be girls or guys,
two drama
side
queens
would be hilarious. Either side. Because you got the butch lesbian stereotype. Mm-hmm. You have the flaming gay stereotype.
Why should straights get all the fun of that bullshit?
Yeah, the gays have divorce too.
Yep, let them have the state all up in their shit.
But it's really funny that gay people don't get divorced at the same rate.
Oh no,
straight people do, because think of how harder it is for them. I mean, I'm bisexual myself. I can't really say anything, but
boy, this has definitely gone off the topic.
Yeah, this is go way. This is like not even out in the field. This is going into a football field somehow.
This is not a football. This is not a baseball game anymore.
This isn't even baseball. It isn't even football. It's fucking.
This is curling, folks. This is curling.
It's curling. It doesn't even have a ball involved anymore.
It's a stone with a bunch of people sweeping in front of it.
I actually like curling. It's fun to watch. It's fun to watch. But then most games, like I was saying earlier about the binary and the conversation you were having earlier. Most games, from what I've seen, is represented in hex, but it's programmed in binary. And
and to be honest with you, like if you're talking about like Nintendo games,
that's mostly in hex.
That's the Nintendo has a 6502, which is the same processor as the Commodore 64.
Yeah.
So the people who actually wrote those games, they wrote them in assembly.
Oh yeah, yeah, that's
They
right.
literally wrote them with assembly, which is those codes like LDA and sub, and they use mnemonics, which are English like, so they were a lot easier to understand and debug than saying, "Oh, this is AF and this is DC and this is."
Yeah, but yet whenever you use, like, say, a Game Genie, all the codes are in
That's gonna
hex.
pull it in hex. Yeah, it's gonna
Yeah,
be
it
in.
pulls it in hex. Then that's and then it translates that into assembly, and damn.
Well, it does what I did with the nibbles, except in reverse,
Yeah,
which is just as easy. Like you take A, that's 10, and you just write one. You just write 1010, and oh, there's your hex digit, and that's what places that. If that's your first nibble, that's the first four
first,
digits of an
the
eight
first
number.
thing that got me into that was GW Basic of all things.
Oh yeah.
Because when I was a kid, there was this little system we had. It hooked up to your TV through the coaxial port,
Mm-hmm.
and it was just a keyboard and another small device that plugs into the keyboard. It's basically like an Ethernet cable. Basically, it goes to it, and
Good
it
night,
was a
Spooky. Good night. He's
cassette.
going to bed.
Good night, Spooky. But yeah, it connected through an Ethernet port, or it might not have been an Ethernet port, just a regular cable. But something like that. I can't remember. It was when I was 8 years old. It was 30 years ago.
Mm-hmm.
This is back before like Nintendo was even a big thing.
Mm-hmm.
But it basically plugged into a cassette player, and it lets you write your own programs in GW Basic. So I was literally writing games when I was 8 years old.
A lot of people learned in Basic. Like my first programs were in Basic on the worst possible computer you can think of to try to learn assembly on, which is why I didn't learn assembly on it, because the TI-99 4A was just a horrible computer to try to actually program assembly on unless you invested thousands of dollars into it.
Yeah.
So it was crippled from the get-go for programming that way. So what ended up happening is my dad bought a Commodore 64, which is exactly the opposite. If you want to program machine code on the Commodore 64, you are more than welcome to start poking around in memory, literally. You
Man,
use the poke command and you can fuck it up if
I
you
remember
want to.
I had this one thing I created back in I was in middle school on the computers, like
Mm-hmm.
late middle school. It was basically a game that the stack, you know what the stack dump is?
Yeah.
It overwrote the stack dump and placed it in memory. That way, every time it does the stack dump, it just kept on compounding in memory until it overloaded the memory and shut the computer down.
You could do all kinds of crazy stuff with those old computers. They didn't have protected memory. They didn't have any of that stuff that
Yeah.
modern computers have.
If you went too long on the thing I created, it would destroy the computer because it would overheat it until the point where it would melt the CPU.
Well, yeah, you could turn it into a fuse.
Yeah. But fortunately, it took a long time for it to do that. So the only thing that happened was it would start lagging until it just stopped playing the game. But it was just a simple stack dump overload.
Let's see. Hide. Guess what, Michael Perez? You are actually going to be hidden on my channel because you don't come in and start saying shit like that.
I missed it because
you're not a mod.
Okay.
He was saying,
let me guess, he's a hater, basically.
Niggers equals baboons. Fuck niggers.
Wow.
Yeah, basically being a troll and being a
asshole,
and just no, I don't put up with that shit. Bye.
Sorry, we already cussed, so Demonetized already.
I can't be monetized. I have
know, I'm
like
joking.
150 subs.
I know,
something
I'm
like that.
joking.
I don't even know how many subs I have.
I have 41.
I don't
Have a
even know.
grand
I don't
total of
even know how I got this many. But anyway,
me neither. I don't know how I got 41, but I've got, yeah. I mean, my channel's been open since 2007, so a lot of them were from back then that just subscribed just because they like to see my light content. I don't know. I don't know.
I
I
have
mean, I'm
100. I have
grateful for all those.
119, and most of that is people from the Great Debate community and people from uh, people related to the Great Debate community, but
Yeah.
not necessarily part of it.
Well, I'm just a gamer, so I mean, I don't really do much of nothing but play games and talk about silly shit while I'm playing games.
Yeah.
I've forgotten how much I hate the taste of Pepto Bismol until today. Ugh, that stuff's nasty.
We're up till 45 minutes, and it is 10 o'clock here, and I have to work tomorrow. So I'm going to cut this short as far as the broadcast portion goes.
All right.
And Colorado Biker Prepper just came in, and I'm ending it. So sorry, Colorado Biker Prepper, but you're
sorry, Colorado Biker.
Bring on the Probulator. That is Bring on the Logic Probe is a reference to Tron, in case you all don't know.
Tron.
The original.
Oh, I freaking love Tron.
Good night, everybody.
Good night.